Good morning. So as promised, I'm going to show you how to implement a star algorithm to solve a puzzle in SolidJS. Later, you can deploy this to websites. Bear in mind that this is not a front-end tutorial, so I might gloss over the CSS and the design part. However, I'm still going to explain the A star algorithm so that you understand the logic behind it. To start, you can clone my template repo from GitHub. It contains basic configuration that you can use later so that you don't have to start everything from the scratch. I will also put the link in the description, but for now I'm going to explain briefly about this template. To start, let's discuss about ESLint config. So this is just for the prettier. I use the recommended configuration from ESLint for JavaScript, and then for TypeScript, I'm also using the recommended settings from SolidJS, this one. And then this is for the globals, and then recommended prettier from ESLint. For the vid config, first I use the Solid plugin so that vid knows how to handle SolidJS code. And then this is for the ESLint during the build phase. If there's any error during the lint check, it will fail the build. But for the local development during the serve task, if there is failure on the lint check, it will not stop the program. And then for the server, I just set the port to 3000. For tsconfig, I want this to be rather strict, so strict true, no implicit any true, strict no checks true, and allow unused labels and unreachable code set as false. Okay, now let's clone this repo or create a new repository using this template. I'm going to name this 8 TypeScript 8 puzzle solver. And then visibility is public. Now we should wait for a few seconds, then the repository will be ready. Okay, now it's ready. We can clone this to our local. Let's clone it. And then let's go to this directory and then open VS Code. The first thing that you notice is that there's lots of errors. This is because we have not installed the dependencies. We just declare the dependencies here and here. This is log file, but we haven't installed anything. So let's open the terminal, pnpm pnpm install. The error should be gone. And now let's try running our project, npm run dev. Okay. Hello world child component. Okay, so now it renders perfectly. Next, we are going to use Solid UI. So this is like shotcn, but for SolidJS. Let's follow the instruction in the docs. So because we're using feed, we're going to click this, and then we can skip step 1. Let's go to step 2 instead. Now, remember we are using pnpm. This is why the log file is in pnpm. So we copy this command, but then when we open the terminal here, pnpm install. Now I know that Tailwind has released a new version 4, but the guide here is still using version 3. So I think they will update it in the future. But for now, we're just going to follow the tutorial. Okay, it's done. Next, we're going to type pnpm sec. Okay, the Tailwind config and the post CSS config files are created. Next, edit tsconfig JSON file. We're just going to follow this. So we can put it anywhere. Sorry, let me close this terminal. I'm just going to put it here. And then let's install this node types npm add d type nodes. So I think this one. Okay. Done. Next, we are going to edit the fit config file. This one. We are going to add the resolve. We add it here. Now, when we run ESLint, there's going to be an error. If you do not believe me, I'm going to run it. Yes, run it. Okay, and I'm going to fix it. Even though some can be fixed, there are still two more errors. So I've done research on this too. I mean, this is linter, right? It's not going to affect much, but it's better if we can solve this right away. I have researched on this, and the solution is to define manually the file name and the dir name. So I'm going to show you how. First of all, copy this, type this, import file URL to path from node URL, and then on the top file, we're going to define this file name and dir name. And then on the bottom, it should be fine. Run, run again. Okay, now we have path undefined. How do we solve this link? So we can import path from notepad like this. Let's run it again. Now we're safe. Okay. Next, step 5. Step 5, run the CLI. npx solidui CLI latest init. This one will, I think, override the tailwind config.js. So npm exec. Oh, okay. I think for this one I cannot use npm exec. I have to use npx. Would you like to use TypeScript? Yes or no? We pick yes because we already use TypeScript. Global CSS file we do not have, but I think we do not need to change this one. Tailwind config location, remove the C, so tailwind config GS. Are you using a custom tailwind prefix? Leave blank if not, we do not. The import alias for components, yes, this one. The same. And then we can use the SolidUI to test whether we can use the component from SolidUI. We can copy this command and then paste it here. Because I previously already installed, I'm just going to overwrite it. Okay, it's done. So next we can add the CSS file. Don't forget, we can import, sorry. And then we're just going to follow this command. Don't forget to import from components UI button. We can remove this import for now. We can start the server. See, this one is already using the button from SolidUI. Next, we're going to implement the A-star algorithm. So we're going to focus on the logic first, and then later we're going to finish the UI. First, we're going to create puzzle solver TS file here. And then what we need in puzzle solver, we need the A-star algorithm, but also we also need the heuristic function. So heuristic function we're going to follow the previous video, which is Manhattan distance. Okay, let's start with the logic. First of all, if you remember from previous video, we need priority queue, but there is no priority queue in JavaScript or TypeScript, at least not natively. So we have to install a library for that. So I'm going to install this library, npm adds data structures.js priority queue. Okay, for this, I'm going to represent the board or the state as a 2D array following previous video. And then I'm going to create a function to string. This will be useful later. So I'm just going to convert it into JSON. JSON stringify state. And then I'm also going to create a new type for coordinate. Coordinate is a type that has two properties, the row and the column. And then we're going to define the neighbors. Now, if you remember from the previous videos that there can only be 4 neighbors. The first one is the top, the next one is the left, then right, then bottom. And then we're going to fill in the A star algorithm first. Oh, but before that, we need to define the goal state first. So goal state is this one has the type of puzzle state, and we just define 1, 2, 3, 4, 5, 6, 7, 8, 0. So in the previous video, we were using the optional type of Rust, but for this video, we just make it simple. We're going to use 0 if it's a blank cell. And then we're going to implement the A star algorithm. Type node. Node here will be used inside priority queue. So it will have state, which is the puzzle state, and then it will have the G, which is a number. This is the cost or distance so far. And then F, the number. Sorry, we do not need to store the heuristic. We just need to store the total cost. Total cost. Fn is, if you remember, Gn plus Hn. The H is the heuristic. And then path so far is the puzzle state, or array of puzzle state. So this is the complete path from the beginning to the goal state. Now we're going to export function solve puzzle. Given the initial state, it should return either the path or return null if it's not found. Okay, let's return null first. Now, I did not mention this in previous video, but I just learned that there's actually a technique to check whether the puzzle is solvable or not without actually solving the puzzle. So check if the puzzle is solvable. Spot function is solvable. State puzzle state. Now, the logic to solve this puzzle is actually in the gigs for gigs. The first example has 10 inversions, therefore solvable. The second example has 11 inversions, therefore unsolvable. What is inversion? A pair of tiles form an inversion. A pair of tiles means two cells if the values on tiles are in reverse order. So for example, the following instance has two inversions, 8 to 6 and 8 to 7. 6 to 7 is not inversion because the order is already in sort. So now there's this code in JavaScript. I'm going to follow this implementation. Let's count equals 0, and then we're going to return if count is an even number. So how do we count the inversion? For let's I equals 0, I'm just going to hardcode it to 3 because this is 8 puzzle. Sorry, this one should not be I, this one should be R. Make it consistent, and then just copy here C. So this is the inner block. Now if the cell is not 0 and the cell is larger than the next cell, so the inversion count goes up. Oh, so I think this one it's a bit of modification, the for each. Sorry, I did not break this. So it goes from 0 to 1, 0 to 1, and then this one is R plus 1. Then C, this one is already correct. Now, I'm not going to focus on the inner workings of this function. You can read the rest of the logic in Gigs for Gigs. I will also put the link into the description. Let me put the link also here, reference. Okay. States if states gi equals to 0, sorry, not equals, greater than 0. So because 0 means empty cell, we want to skip it, and states gi is greater than states ij. Now remember we are using, sorry, this one should be cr, this one should be rc. So which object is possibly null? So I think this one is C and R. Okay, we need to add two banks because we are sure that this is not null because we limit the traversal count plus 1. Okay, I think the logic for is solvable is complete, and then if is solvable, sorry, this one should be a function, initial state return null. We're going to handle it later. Okay, and periodically we can run pm run linfix. Okay. Also, I think there's an error in the config. We'll check the tailwind config just later. Okay, next we can continue with the A star. Const start node state, which is the initial state. G is 0, F 0. Actually, F is not 0, but for simplicity, because this F will not have any bearings on the algorithm. But to be precise, this F should be G plus H. We have yet to count the H, right? Actually, can we? Later we will go back to here. And path so far is the initial state. Const visited is new set of string. Const queue, this is where we use the parity queue that we installed earlier. Queue, see? So we can remove this comment. Parity queue of type node. We're going to fill in the second parameter first, which is the initial value. So we're just going to put the start node. The first parameter is the comparison function. So this one is pretty similar with Java, where the -1 means it's going to be put in front of the queue. Return -1 if bf f return 1, return ag. So if the f value is the same, we're going to compare it from the g. Bg -1 1. Yeah, let's see if the error is. Oh, sorry, I forget to find the new. Okay. While queue is not empty, oops, sorry, this should be a function call. Const current is queue pop. If we can either break or we can continue. I'm just going to do continue. First, this should not happen, by the way. If this happens, then the implementation of the A star is incorrect. Next, we check if visited has the string representation of the state, current state. Sorry, I also forget the phrase. Then continue. Now we check if we reach the goal or not. So this is where we need to implement the heuristic function. Function, just call it heuristic. It will return a number. That distance is 0, and then we're going to return distance. Now what is the logic? Remember that Manhattan is d equals 2 plus y1, sorry, y1 minus y2. So what we're going to do is we're going to count the total distance. So let's rename it. And then for every number 1 through 9, we're going to check each location. At the location of the number from the state and calculate the distance to the goal. So we need to create a new function. Function find number from the state. It will return a coordinate. Can use this placeholder first. Sorry, this should be including number. Number. Const num coordinate equals find number. State I. Number target coordinate is, this one is not the state, this one is the goal state. Then we just use this formula. Const distance is math absolute of num coordinate r minus coordinate r plus math absolute num coordinate c. Sorry, this one should be minus. Num target coordinate c. And then total distance should be added. Okay, now let's complete this function find number. Okay, for let r equals 0, r equals 3. Sorry, for let r equals 0, r is less than 3, and then just going to copy paste for the c. If states r c equals num, we're sure that this is not null, return rc. Return -1, but this should not happen. And okay, next, if heuristic of the state of the current state is already 0, we reach the goal. Return current path so far. Now, next we're going to visit the neighbors. Const neighbors equals generate next possible states. We have not implement this function, so let's implement this function. You have the state puzzle states. This one is puzzle state. At least 0. I think this one can be const. Return list. To finish this function, we need to create another function, which is to find empty cell. Empty cell. State puzzle state. Actually, we can reuse this one. Const empty cell. Remember that empty cell is 0, right? So just fill in with 0. And then for neighbor of neighbors, just copy everything. Now check if outside of the box, if r equals 0 or r exceeds 3, r exceeds the rightmost. Sorry, turn. This one should be continued. If you see 0 or C greater than or equals 3, continue. Create new port, then swap the values. New state is structured clone. So structured clone means that you will have a new puzzle state, but with the value copied. So it's not a reference. This is similar to the copy and the clone mechanism in the previous video. State constant is the new state. C. This one is wait. Where is this? And then the empty cell will be filled in with new R and new C. And then new R and new C will be filled in with temp. Sorry if the code is a bit convoluted, but basically we're just swapping the values. After that, list push new state return list. And after that, we visit the neighbors. Let neighbor of me. Sorry, this should not be called neighbors. It should be called the next states. Even this should be const. Const g equals to current g plus 1. So the actual cost will be the current cost plus 1 for simplification. Don't worry, this still works. Const h equals heuristic next state. Const f is g plus h. Const next node is state equals next state, g equals g, f equals f, and then path so far. Sorry, this one. So far is to be current path so far and next step. And then QE push next node. Okay, I think the A star is finished for now. How do we test this? We can test this using unit test. I just realized one thing. Before we generate next possible states, we need to add the current state into visited. So this one should be visited add to string of current state. Next, we are going to add the unit test. So to add the unit test, we need to add a few configurations. Most of them are in vidconfig. So below here, below build, we add test. And then we set the environment as GS DOM. Now, we do not need this for now, but we are going to use this later when we want to write unit test for the UI. And globals true and set up file This one is also for UI test. Setup test. Yes. Now before we forget, let's add this file first. Setup fit test. Content is simple. We're going to add the necessary libraries later. And transform mode. This one is the regex. Web. And then coverage, we're going to enable as well. Enable true order text HTML. Server. Now this one is to prevent error from happening, because when I tried this earlier, there's an error in this library. So by setting the this dependency as inline dependency, we prevent the error from happening. And depth theme measures. Okay, the configuration should be done, but there are some dependencies that we need to test to install. So the first is the coverage, and then the vtest UI if needed, and then the vtest itself, and then also GS DOM, and then solid testing library, and next is testing library just DOM and Serifan. Okay, so to remove this warning, we can downgrade the ESLint to 9, and I think what else? Yeah, and also this one. So if we refresh the node modules, now the warning is gone. Okay. Okay, one small typo. This should be optimizer without S. Now we're going to implement the unit test. STS. Now let's see. Puzzle solver. This one is export. This one is exported as well. Okay, we can start writing the unit test. This is the goal, and this is the to string. We're just going to copy paste this, or we can export this. So export to string as well. We don't need to. I think for the goal state we can also wait. Where is it? Goal state we can can also export this. First, describe 8 puzzle logic. Describe is solvable. It returns true for the go step. How do we test this? Simple. Expect is solvable for go state to be true. Now, how do we run this test? We're going to add two new comments. Test is test, and another one is coverage. Coverage. Now let's see if this works. Sorry. npm run test. Okay, one failed. Something is wrong. Okay, so it seems I found the error after asking Gemini. So the trick is to flatten the array, and then only after that we count the inversion. So for this one, first is that was flatten, that flat. Okay, I think the gigs for gigs one is not very reliable. And then after that, count 0. Okay, next do the for loop. For that I equals 0, I flatten length from 0 to flatten length. For at j equals 0, j is more than flat. Sorry, this one is I plus 1. I j, there's a guide here from Gemini. Oops. Compare a b as inversion if a is larger than b, is strictly larger than b, and b is not the empty space. If a is larger than 0 and b is larger than 0, a is possibly undefined, we at the bank it count. Let's see if now the unit test works. Sorry, wrong comment. Okay, one pass, and we have the coverage report. For now, we will not cover all the lines. And next returns true for solvable shuffled state. Close to 1, 2, 3, 4, 5, 6, 7, 0, 8. This is the solvable state. Expect a solvable shuffled state to be true. Alright, two tests passed. Next is to return false for unsolvable shuffled state. Shuffled state is, we're going to copy this one, but we're going to back it to the goal, but then we swap the first two numbers. Okay, 3 passed. This is to be true T. Now we can continue with the solve puzzle A star. Right. Solve puzzle. Returns a path of length 1 starts state if already solved. So for this one, solve puzzle close step. Expect path to, sorry, not to be nullable. Expect path. Now we can use the bank safely. Path length to be 1. Okay, for pass, just to check the for pass, expect to string path 0. This one is going to be, sorry, to be to be to string path to be string goal state. That's it. Okay, this one is also correct. So next, it returns null immediately for unsolvable puzzle. Now we can copy paste. This one is to be nullable. Specifically, we can set to be null. And what about the puzzle? So the puzzle is going to be different. 2, 1, 3, 4, 5, 6, 7, 8, 9. Alright. Next we want a complex puzzle. It returns the path for complex puzzle. So based on my research, I have this puzzle. Solve puzzle. Okay. Oops, sorry. PM. Alright, expect path to be null. And this one is should be not to be nullable, and I think the length should be 32. 30, 32. Length should be 32. Okay, let's try it again. Alright, 6 passed. Now let's continue on to the UI. So first, this is just a personal style, but I'd like to convert everything into function like this. Remove that, and then next we are going to run the service so that we can preview the UI easier. Okay, now okay, so this is UI. The first item is to create the model card when the solution cannot be found. So how to do that? I'm just going to copy from my private repo. So basically, like uh, we need to create a signal. This signal will be the reference for when a solution is found or when the solution is not found. And then this is the diff. Okay, I'm going to run the lin fix. Okay, no unused parse. We will use this soon. So show when no solution found. Don't forget to import the show, and then what do we want to show? We want to show the card class. Now we do not have the card. What can we do? We can add, we can add card like this. Done. Now we can import it. And then we're going to add the header and then the content. Oops. So let's tidy up this first and tidy up this first. And then let's see what would happen. Oh, first we decide set this to true. So this is what will be shown if there's no solution found. And then later there will be a button to go back. So let's add the button card shooter. Go back. Okay, now that we've seen the results, you can set this to false. And then we're going to add another conditional render. We're going to add this. This will be the main display. Card header, title, okay, let's run the link first. Okay, now it shows like this. I'm turning on the hot module reload so that we can easily see the display. Now what's next after the title? Oh, you just need to add a small paragraph showing the paragraph here. Okay, and then let's add the content. The class. Now we're going to add the div. Now this is where we should implement our board. Sorry, const board set board is create signal is puzzle state. 780. Don't worry, we will fix the lint later. In fact, let me move this to another window. All right. So we have the board. We have the board signal here. Then what? Then for each board, for each the board, what do we want to do? We want to render. for, wait, let me check, row number. Okay, so I forget previously I typed like this, but I should uh, add the curly brace. So now it shows like this. But then we're going to create a custom component for the tile. So here I tile TSX, and then spot default function, sorry, tile. So this component will be the component for each number. So we want to beautify the display basically. Okay, later you can see on the GitHub. Now I want to put the tile into here. Tile, value number, the number will be like this. So the dashed lines is because of the conditional class. This one, the dashed lines. Now what happens after we edit the tiles? We show the navigation controls. Show when solution path length is greater than 0. We have not created this signal first. We have not created the signal, so we have to create it first. Set solution path. Create signal. If I remember correctly, this is puzzle like this. This one is empty. So what will be the contents of the show? This block, it will be the left and right arrow. Later we will see. So, for example, I think I can show you 1, 2, 3, 4, 5, 6, 7, 8, 0. Okay, there's nothing because this is still empty. This one, and then solution found in solution path length -1 steps. Now the reason why this is -1 is because back in the A star algorithm here, we added the initial state. Sorry, not this one. This one. So for example, if the path so far returns 30 items, that means that there are actually 29 steps, because the first the first item in the path is actually the initial state. So let's see. Solution found in 0 steps. Remember that we fill in the dummy, right? This is just to show you. For example, more realistic. Let's see. Sorry, 780 our pretty complex. 1 steps. Okay. Next, div class flags. This is for the navigation. This is for the navigation, and then there's button with the variant outline, and then we need to handle previous step and disable if the solution step is 0. For the solution step, we need to create the path first. Sorry, we need to create the signal first. Cons solution step, set solution step, plus create signal 0. 0. And then handle previous step, we will create a dummy function. So see, this is the button that we created. And then there's also another button. There's also another button, and then later we will put in the span in the middle. Again the same, and the next step we will implement this later. Oops. What is this? Okay. I need to refresh. Okay, so there's nothing here. So for the next step, what we need to do is to change the solution step to its increment. Set solution step equals solution step +1, like this. This one is -1. Okay, sorry for the interruption. So I just tried a few things, and now we will continue with the navigation. So as you can see, we can click the button, but the state will not change. What we need to do is to add this block create effect. So this one is similar to React's use effect, but the difference is that we do not need to add any dependency array. We want to get the path right, solution path, and then we want to get the state. So path state, solution step. So as you can see, the state could be undefined. So for now, we just add the bank because we know it's not going to be undefined. And then we set the board basically. State. Let's see. See, now it can move between the state. Now let's continue with the UI. So what will be after the navigation buttons? We're going to add a bit of a gap, and then we're going to add two buttons. The first one is to shuffle the configuration, but the shuffle mechanism we haven't implemented it yet. Later we will implement this. And the second button is to solve the A star. Sorry, solve the game with the A star. So first we add Steve, and then we will have another grid, and then we will add two buttons. The first one is shuffle, the second one is solve. Solve with A star. This one is variant outline. Sorry. On click handle shuffle, we have not implemented this, and disabled is solving. So we have not added these two. Oh, sorry, I think I added the wrong section. Let's create a dummy function. Function and sorry, what's the name? Handle shuffle. Handle shuffle. We're going to add the logic writer. And the second one is solving. So is solving create signal false. So is solving will be used when the program is currently solving the game. Basically, that's it. And for handle shuffle, I think we also need to add another function here. Let's add it above the solvable. Export function shuffle. And then we'll return the puzzle state. First, we need to set the state as the clone of the goal state, and then we shuffle. Three plus, and this one can be state like this one can be R as well. I'm just going to change it into R. Let C equals math random. So this one should be math floor of math random. Or plus one. In fact, I think this one should be from state line and then larger than one. And then we can swap states are C oh wait, okay, sorry for the interruption again. I just did a small research on this shuffle function, and I think the best way is to flatten this, and then we can swap the elements. For example, like this step change. Oops. Step I. And don't forget to add the bank because we are sure we are guaranteed to find this. And then we need to ensure the solvability. Solvable. If not solvable, we generate again. Simple fallback, just regenerate everything. Okay, the reason why this does not work is because this receives to the array. I think um, I'm going to refactor this. Return is solvable flatten. Take the number. So this one I can reuse this function flatten. Flat step. Just regenerate everything. So this is uh, a bit dangerous, but I think it's fine for our small example. State 0, state 1, state 1, state 0. And then what's next after this? We're going to uh, convert this back to the array. Turn chunk counts. For let I equals 0, I then state length I increment by 3, not by 1. So after this chunk should be pushed to state slice equals 3. I think this is the way to go. After this, what else? Yeah, so we have created the solving. Now we just need to handle the shuffle. On new state shuffle set port new state set no solution found false set solution path empty. I think we should make this empty too. Then set solution step. Basically, we reset everything. So let's see if we can shuffle now. Oh wait, what's wrong? Okay, I just noticed a bug. So we cannot use create effect here. We have to updates it manually. So for example, const next, const new step, write new step, and then if new step is 0 and new step is less than solution path length, we update the board. So set board is const path is solution path, and then const step is solution step, and then set board is the state. This one is the same but plus 1. So later we will refactor this. So no create effect. Okay, let's see. Okay, now the board shown again. But then the navigation button is gone because we remove the mock. Now we can shuffle. Okay, next let's do the solving. So this one should be is solving. Okay, what's the style? On click handle solve. We have not implement this, but it's fine. We'll implement this later. Okay, disable is solving, or if the board is joined, I think this is to string board equals to string goal state. Let's see if, oh wait, I think wrong function. Okay, now it's working. We just need to format this and run pnpn run and fix. Okay, we format everything and then handle solve. Certain process. What will be the contents of the handle solve? We're going to set solving or is solving true. Let's rename this solving to true, and then set no solution found is false, because this one will be set to true later, and set solution path to empty. Allow UI to update before heavy calculation. Set timeout. So inside this block will be the heavy calculation code. First, we need to check the solvability first. If not solvable, we can skip the calculation. So if can skip the calculation, set no solution found true, and set is solving to false. And then we can do early return. Then we're going to run the a star, sorry, path is solve puzzle current code. If path is found, okay, if path is not found, set no solution found is true. The set is solving is false. Oops, sorry. Set solution path is path. Set solution step is 0. Okay, I think that concludes all. Ah, oh wait, now I cannot move the. We managed to solve it, but now we cannot move. I need to check what happened here. Oh, now I know why. Should be new step. Should be new step. Still does not work. Wait. Okay, now I found a bug. So this should be a function call because it is a reactive state. If we check here, now the board moves. But I do wonder why it's not uh it's not throwing error though. Anyway, we can remove the console log here. Next, what we want to do is to add a custom input so that below here user can input their own board configuration. Now, I'm going to add the label and then this will be the custom input. I'm going to add the paragraph first. Okay, set custom state and this will be the paragraph. Now I will add the input. So let's create a new class here. Sorry, let's create a new file called input. And then let's add the import. Component XML attributes, XML input element. Sorry, this one does not have the semicolon because this one will be props. Cons local others is spread props. Now I think the CSS will be a bit long, so later you can see on GitHub. Basically this is for the input text field. Okay, let's import the component here. Value equals to input string. We have not create this first. So we're going to create the signal. Okay. Then what's next? And then on input, set input string the current target value. I think this can be edited as HTML input element. Let's see if we can do this. HTML input element, or maybe this one. Can or not? I'm not sure. If I can. If I cannot. Oh, there should be event handler. But anyway, this one will work for now. And then we're going to add placeholder. Oh wait, I think I need to format this. Right, nice. Placeholder 547231. Something like this. Oh, sorry, the paragraph should be outside of the div, but something like this. Okay, custom state, and then it will be disabled if it's solving. Next, we are going to create a button to set set to, but we have not handled the input, so yeah, let's add it now. Disabled is solving. On click handle apply input. Now let's implement this function. Function handle apply inputs. I think this function takes an argument. Let's add the async function. First, let's parse the input. So first, let's console log the input. So 806754231. That's the input. Okay, we got the input. What's next? Next, we need to convert this input into an array, and then from array, we're going to generate a chunk. So first is to do. Convert to array 1D array, convert to chunks. So how do we convert this into array? We can use input split. First we're going to trim, and then we're going to split. This one we're going to use regex. Okay, this should be the regex, and then map parse int and nums. Okay, we're done. Now convert to chunks. Oh, first we need to validate first. Um, okay, I think it's going to be better if there's a function. It's a dedicated function for this. This will return the puzzle state. Input string. Input is parse input string. If num's length is not 9, then no. Okay, need to return this to no. Okay, okay, now we need to convert into chunks. There's some additional validations. For example, like if nums sum, so if one of the number is not zero, sorry, it's not a number. If one of the elements is not a number, then it will return null like this. And then adding one more another condition. If it's less than 0 or greater than 8, we also return null. That means invalid. And then if the size is not 9, that means there's a duplicate. Return null as well. And then convert to chunks. Let const chunks. Return chunks. Or let I0 nums length. Oh, this one should be +3. I think there's already a logic to convert into chunks. We can copy it for now. So this one is the nums, and we're going to slice it too. So okay, so parse input, then what? And then this should be new state. If new state, I'm going to work on the else condition first. We can alert the user. File format. If new state, then set board as new state. Sorry. Oops. I think there's invalid import. Set no solution found is true. Set solution path 0. Sorry, this one is empty array. Set solution step to 0. Okay, I think that concludes all. Okay, what else? Let me check. 806. Let's just copy it from the input now. 806574231. Oh wait. I think there's a bug here. Set input string. This button is okay. No, apply input. Parse input. Oh wait, I think I know why. This one should be false. Hi, so now we need to create the unit test for the UI, because even though that we already tested the functionality, we still need to add tests for feature regression. Alright, so how do we write the test? We need to use vtest and SolidJS testing library. So first we create app.test.tsx and then import the necessary functionalities. Next, we need to mock the window alert because this one is not mocked in GS DOM. Need to mock. If you remember GS DOM, this is it's in here. The test environment is GS DOM so that we can render the screen basically. Now describe the app. Now, before each test runs, we're going to clear all mocks. And after the each test runs, we're going to clean up. Next, we're going to write the first unit test, which is to render the initial game state. So first we render the app. Oh, I think it should be this, like this. And then we expect screen to have the title. This is the title at puzzle solver. To check that, we can use the function to be in the document, and then we also want to check the subtitle. Algorithm demo. Now we can run the test using the command pnpm run test, or we can add the dash dash double dash ui to see the UI like this. So this will be hot reloaded, which means that whenever you update your test, the dashboard here will be run again. And since we enabled coverage, we can also check the coverage here. I think, and we can also toggle the dark mode and light mode. Okay, so for now, the first test runs correctly, and then we can also see the code. Next, we will create another unit test. Sorry, I keep saying unit test. It should be UI test. Now, the second scenario is when we shuffle all the numbers. Shuffles all numbers successfully. Again, we render the app. We make sure that the title exists, because when we shuffle, the title still exists. And oh, by the way, I forgot the assertion. Expect. We want to check if the screen renders the numbers correctly. Get by text 1 to be in the document. Then we can copy paste this. 2, 3, 4, 5, 6, 7, 8. And copy, because both in the initial state and after shuffling, all of those numbers should exist, right? So for example, if we shuffle this, all of the numbers exist, just in different position. Okay, what's next? Updates the board when a valid custom state is set. This one refers to this. So for example, if I type 1, 2, 3, 4, 5, 6, 7, 0, 8, this will update the board. Now we're going to create a new test for that. It updates the board when custom state is given. First, we render the app, and for now, we're not going to add these assertions because it's already covered. So now we want to fire an event. So first, let's see how do we get this element. So the way we get this element is we get by the placeholder. So we can say something like this: screen get by placeholder text. The parameter will be regex I as HTML input element. And then const set button. So set button refers to the button here. We can also inspect the element to see if we can get this element easily. Looks like we can get by text set like this. Now, how do we simulate an input? We fire an event. Because we already imported here, we just use it. Fire event, input, was the element, and then the event itself. Target value will be, for example, 456,708. And then after that, we click. We also need to set the button here. And then after that, what we need to check. So for example, 1, 2, 3, 4, 5, 6, 7, 0, 8. If it's set, now the board gets updated. Now, similar to shuffle, we can check whether all numbers exist. In fact, we're going to do that because the assertions for these scenarios are similar. So now we can check the dashboard to see whether the unit tests, whether the UI tests all are running correctly. Okay, so next scenario will be to solving the puzzle. And allows manual navigation. So for this one, we're going to copy paste after we set, after we click the set button. What we want to do is to click solve with a star button. Ah, so console button is get by text solve. Sorry, it should be this one. Solve with a star. Then we go back to the unit test. Get by text. Solve with a star. Then we want to click this. So what happens when we click this? Let's go back to the UI. Wait, let's go back to the UI, and then so this becomes enabled, and then this text shows up, solution found. So expect screen get by text solution found I to be in the document. Let's see if this is okay. Not yet. Let's try again. Oh, okay. I think I made a mistake. I think I should be a bit more patient. Wait for. So it's not an instant process, right? So that's why I should wait for it. And because there's an await here, now we need to do async. So now if we check, now it shows green because we await. It's pretty consistent with what it's showing so far. So yes. And then we also want to test the navigation button. So first of all, we need to get the button itself. Next button is screen get by title. The reason why this is get by title is because, wait, have I set this? Because we set the title here, next step and previous step. Next step, previous button. And then we, let me show you the UI again. And then I think we're missing something. So when the user moves between the solution, uh, the user wants to know this is at which step. So I think this is something that we can add in the unit test first, in the UI test first, then we will adjust the UI later. So I'm going to add the step text first. This is again regex. Now we need these three components to be in the document. Be in the document, next button, and step text. Of course, the text is going to fail because step text does not exist. Now let's add the step text. Here, we'll add the span, step, solution step, solution path, length, this one. Now the reason why this is -1 is because I think I said this earlier, because we put the initial state into the path, so we need to subtract by 1. I think I already explained this when talking about this one, but yeah, just to remind you. Now will it succeed? Yes, it succeeds. Okay, now we can try, oops, where's the code? Now we can try step 0 to 1, step 1 to 1. We should also test the navigation button. Not only that we need to check whether they exist or not, but we also need to test their capabilities. So first of all, we want to go to the next, expect next button not to be disabled. And then fire event, click. And then after that, we need to await. step text. This should be step 1. Sorry, expect to be in the document. Already. Now, because there's only one step, right? That means that we cannot go to the next step because there is no next step. This is the last step. Already at the last step, ensure next step button is disabled. So expect we can copy this. Expect next button to be disabled, and then we want to go back to previous step not to be disabled, and then we go back to step 0 again, and then expect previous button to be disabled. So let's see. Let's see the dashboard. Okay, so I think the assertion works. And then next scenario is to displays error card for unsolvable puzzle. Displays error for unsolvable puzzle. First, we're going to copy this because we're going to copy from the previous test. Now to make this unsolvable, we just swap the first two numbers. Okay. No solution found. First, we're going to await or expect print. Oh, this one should be async as well. Get by text. No solution found. Be in the document. And then what else? Oh, the go back button. Or maybe we can also assert the text. Expect print get by text to be in the document, and then we can get the button go back button. Go back. And then we can also assert whether to make sure that this is not disabled. So if we see the UI, we can click go back. And then if we check the unit test, if we check the UI test, it will show that the test returns correct. Okay, now after we go back, we should see the initial state. Okay, we can set a wait for I think this one is overkill, but just to Sure. All right. Unable to find an element with the text. What happens when you go back? A puzzle solver. Oh, okay. So I have not clicked the button. Event click go back button. That's why it returns error. Now it shows green check mark. All right. The last scenario is to handle invalid input. Yes. First, we're going to render the app again and then the input as HTML input element. And then we can copy paste from, oh wait, we also need to set the button. And then we just put random text. And then click set button. And then what happens after that is we expect a window alert. And then in valid format. Now let's see. Okay, because when we okay, let me show you the Firefox. Because when we input the invalid text, right, like this, invalid format. So yeah, the unit test shows the result. All right, I think that will be all for this project. Thank you for following, and I will deploy this soon. And I will also give the link to the GitHub as well, so that you can double check if I made any mistakes